Alright, today we're going to talk about special cases of compound inequalities that relate to graphing. So first off, a review. A compound inequality is two inequalities joined with an AND or with an OR. And so AND problems, the final answer has to satisfy both of the inequalities, and so you're looking for where they overlap. You're looking for where they cross. For OR problems, the final answer can be either both of the inequalities. So you're looking for a combination. So you can have both answers here and you need to overlap over here for AND. So let's look at some examples. The starred ones are the tricky ones. So for number one, you've got x is greater than 5. So when I draw a rough sketch, here would be a 0 on my number line, here would be a 5, and here would be a 12. So I'm going to graph it above it to show you the overlap. So if it's greater than 5, I'm going to have an open circle on a 5, and I'm going to shade to the right. So everything greater than a 5, not including a 5, would be the answer. And it has to be less than or equal to a 12. So I'm going to have a closed circle on 12, and less than would shade to the left. Okay, so for an AND problem, I'm looking for my overlap, and so that's going to be this area right here. They overlapped between a 5 and a 12. So my final graph will have a 5 and a 12. The 12 had a closed circle, the 5 had an open circle, and then they were overlapping in between. Okay, so any answer between 5 and 12, not including 5, would be your answer. So let's write that final inequality. I'm going to write it in compact form, and so what that means is your x is in the middle, your bigger number 12 is on the right, your smaller number 5 is on the left, and then I'm going to pick my inequality signs. So remember, this one does not change. I dropped down my less than or equal to because it was opening up to the 12th. I've got to turn this problem around because the sign was opening up to the x. It still needs to be opening up to the x. Okay, so that's how you write a compact inequality for an AND problem. So let's look at number 2. I want to interpret the graph. So now I have a graph and it wants me to write the inequality. So I'm doing much like I did on number 1. So I need my bigger number to be on the right, which is a 1. I need my smaller number to be on the left, which is a -2. My x is going to be in the middle. And then I need to pick my inequality signs. So this 1 is not closed in, so it's just less than. And then this last one is equal to, so I'm going to have an equal to under that, -2. Okay, so that you will always have less than signs if you write your bigger number on the right and your smaller number on the left. Okay, all right, let's try some tricky ones. So 3 and 4, I have some AND problems. Let me get rid of that. So here would be a 0 on my number line. A -3 would be to the left of it, and then a +4 would be to the right of it. So now I'm going to graph it above and see what happens. So x has to be greater than a -3, so open circle on -3, shade to the right. And x has to be greater than a 4. So I'd have an open circle on 4, and it also says shade to the right. Okay, so this doesn't look like an AND problem that I've seen before. Typically my AND problems are facing each other and I'm looking for the overlap. So this is why it's a special case. But I'm still looking for the overlap since it's an AND problem. And so they're overlapping in this area right here. So basically I can ignore this x is greater than -3 because if something is greater than 4, it also makes it greater than -3. So my final answer, I'm going to ignore that -3 and just work with my 4. It's an open circle, shade to the right. Okay, so my final inequality, I only care about x being greater than 4. Okay, so if you've got an AND problem and they're going the same direction, you're looking for the overlap, which is going to be the furthest one away. Another way that you can see this is a special case problem is if I try and write it in compact form, it's going to look a little bit different. So I put my bigger number on the right, I put my smaller number on the left with my x in the middle. Now, I bring down my inequality sign, for x is greater than 4 because it doesn't switch. And then right here, my sign was opening up to the x, and so it has to be opening up to the x down here. And so that looks a little wonky. I don't have less than signs. So that's another way you can tell if this problem is a special case one. All right, another special case one for and, number 4. So I've got x has to be less than 1 and x has to be greater than or equal to 4. So I'm going to draw 0 on my number line to help me out, and then I've got 1 and 4. So 1 will be to the right, 4 would also be to the right. So I'm going to graph them individually. X has to be less than a 1, so an open circle on 1, shading to the left. And then I have a greater than or equal to sign, so equal to, so close in. And then shade to the right for greater than, okay? This is not what an and problem should look like, right? They should be going towards each other. This actually looks like an or problem. So when you have an and problem that turns out like an or graph, it's going to be a no solution. So you don't have to draw anything on your graph. My final graph, there is no answer. So something can't be less than 1 and bigger than 4. For example, you can't be 0 is less than 1, but is 0 greater than 4? No. Okay, so if you have an and problem that comes out looking like an or graph, you got a no solution. All right. Let's try these or problems. Let me know if you have any questions, by the way. Okay, so number 5, I have an or problem. So I would expect it to look something like going opposite directions. So let me draw my 0 on my number line. And then I have a -3, which will be to the left. I have a +6, which will be to the right. So x has to be less than -3. So open circle on -3, shade to your left for less than. And then x has to be greater than a 6. So open circle on 6, shade to the right for a greater than. Okay, that looks like an or problem. So I just combine them together. So I've got my -3, my 6, and I rewrite my solution. Okay. Remember, when you have an or problem, you cannot write it in compact form. So I'm just going to rewrite my inequality. So x has to be less than 3, or x has to be greater than 6. So any number less than 3 works, and any number greater than 6 works. Just make sure not including 3 or 6. All right, I'm going to jump to 7 first, and then we can try the tricky problems. So on 7, it wants us to interpret the graph, so I need to write an inequality for it. I'm going to start with my left side, and so I have an x and a -5, and since it's going to the left, that means it's a less than sign, and it is closed in, so it's equal to. I need the word or, and then I have an x and a -1, and since it's going to the right, it is a greater than sign, and it is closed in, so it's greater than or equal to. Okay, so that's how you write an inequality from a graph. If it's or, you have to have the word or. All right, time for the tricky problems, special cases. So let me go ahead and graph this. I have a 3 and an 8, so my 0 would be on the left. I'd have a 3, and then I would have an 8. So x has to be greater than 3, so open circle on 3, shade to the right for greater than. Or x has to be greater than 8, so open circle on 8, shade to the right. Okay, now this looks like our and problem that we did up here, right here, and I was looking for the overlap, and so I went with my last number. But now I'm looking for the combination of them. So I can have both of them. So if something has to be greater than 3 or greater than 8, I just care that it's greater than 3. Because any number greater than 3 is also going to be greater than 8. So I look for the combination of them. And so I don't really care about that greater than 8, so I'm going to drop down my open circle on a 3 and shade to the right. Okay, so combination, you're not looking for the overlap, you're looking for kind of the most part of the graph. So my final inequality, I only cared about when x was greater than 3. Okay, so that's a tricky problem. Or I expected to go opposite ways. They went the same way, so I went with the combination of the both. All right, last special cases or problem. Got a 5 and a 7. So here would be 0, 5, and 7. So I'm going to graph x is greater than or equal to 5, so a closed circle on 5. And we're going to shade to the right. Then I'm going to have an open circle on 7. And shade to the left for less than. Okay, now this looks like an and problem since they're facing each other. However, it's an or. And so I would expect or to go opposites. So if it's a combination of the both, this is covering every single number. If it's greater than a 5, it's over here. If it's less than a 7, it's over here. This 7 is even included in this line right here, because if it's greater than a 5, it's including 7. So it covers everything. And so that would be all real numbers. So my entire graph should be shaded in. It covers all of them. It covers 5, it covered 7, and it covers anything greater than it and less than it. So if you have an or problem that goes towards each other, like an and, that would be an all real numbers example. Okay? All right, those are the special cases. Let me know if you have any questions. Otherwise, you're going to practice. And so let's turn the page. And so I want you to try 1 through 6 on your own. There are some normal problems. There are some special cases problems. Take a look back at your notes to see which ones looked similar. And so write your final answer over here in the graph and then write your final inequality over here. So try 1 through 6 and press pause. Alright, so here are the answers that you should have gotten for 1 through 3. So I had an and problem, and so I was looking for the overlap. The overlap would be right here. So I just care that if it is greater than a 12. So that's what I did. I wrote x was greater than a 12, and I only wrote x was greater than 12 on the graph. On number 2, you had an or problem, so you were looking for the combination. So I'm not looking for the overlap, I'm looking at the combination, which means I want the most, which would be that first top graph, because if it's greater than a 3, anything is also going to be greater than a 12. So I only cared about the x was greater than a 3 problem, and so I regraphed that on number 2. On number 3, you had an and problem, but you had a graph that looked like an or, which means that would be a no solution because there is no overlap. On number 4, I had an or problem. It looked normal. It went opposite ways, so you just had to recopy the problem over. On number 5, you had an and problem. You were looking for the overlap, which would be right here. So closed circle on a 3, open circle on a 12, and we were going to shade between. So every number in between here would be a solution, but not 12. And then last problem, you had an or problem, but it looked like an and because there was overlap. And so if they're overlapping and it's a combination, it is all real numbers. So it can be greater than a 3, which covers anything, and also less than a 12. Okay? So remember, the no solution is when there's no overlap, which would be an and problem going or way. And the all real numbers, which is infinitely many solutions, is when you have an or problem going opposite ways, or the same way. Alright, so let me know if you have any questions. Otherwise, you can now practice graphing compound inequalities. Thanks for watching.